Hello class, today we're going to start chapter 8, which is still hypothesis testing, but instead of having one sample, everything is now doubled to 2 samples. You are going to find this is very similar to the entire last chapter. To start off with, you're still going to use your null and your alternative, but now your null, HO remember, it states that there is no difference between the means. No difference. This is still all of your equal parts. So you are still going to see your equals, less than or equal to, greater than or equal to symbols. The alternative, your H sub A, this is pretty much the opposite. So this stuff does have differences, so they are not equal, less than, or greater than. There is some sort of a difference. There's also 2 different ways you can write your hypotheses. Okay, the first way, and this is the one I particularly like, you show mu1, the mean of group 1, is equal to the mean of group 2. Because you have 2 samples, you have 2 means. And then your alternative would be the not equal to difference between mean 1 and mean 2. And this works for all of those symbol combinations. You can have mu1 is less than or equal to mu2. That would make your alternative mu1 greater than mu2. And then the third possible combination, mu1 is greater than or equal to mu2, and mu1 is less than mu2. Okay, so this is kind of nice because you have both samples kind of identified in your hypotheses. Or the other option here, let me speed this up a little bit. Your other option is you can write it to show the difference. Differences in math typically means subtraction. So you can do mu1 minus mu2 is equal to 0. If you're equal to 0, there's no difference. 0 is a neutral number. And then you would have mu1 minus mu2 is not equal to 0, showing that there is a difference. Okay. This format works again for all symbol possibilities. So mu1 minus mu2 is less than or equal to 0. Mu1 minus mu2 is greater than 0. Mu1 minus mu2 is greater than or equal to 0. Mu1 minus mu2 is less than 0. If you choose the option where it shows the subtraction, it's always the number 0 on the right-hand side of that inequality. All right, so you can choose whichever one you like better to write those. In order to run a 2-sample z-test, okay, well, there's a couple criteria that you need to have. Both samples must be randomly selected. Both samples also need to be independent. Okay, so one sample can't affect another one. They can't be related to each other. That's really just common sense. Just think about that for a second. And then also, because we're in a z-test, your samples must be large. They need to be at least 30. So n is greater than or equal to 30 is how we have been referencing it. And that goes for both samples, because remember, everything's by 2s. Now, when we do a test, we're doing a 2-sample z-test. 2 samples, and we're still in the world of z's because everything's large. You're going to notice this is a very familiar format to you. Step 1, state your null and alternative, label your claim. That is always going to be step 1. Step 2, label your level of significance. That is still alpha. It's still given to you. Step 3, you can find your critical values. Because you're in the world of z's, oops, if I spell it right, you can still use your inverse norm for that. That's a repeat from last chapter. The new guy. Really the only thing that ever changes is that test statistic. You are going to go where everything so far has been located. Hit your stat button, go over into your tests. Okay, this is where all of our intervals and hypothesis testing from chapter 1 chapter 7. And here you're looking for the one that says 2-sample z-test, okay? So 2 samples, it's a z-test. So you got to choose the correct option. And then once you have that, then you compare, decide what are you going to do to your null, what are you going to do to your claim. Now when you get into the calculator, because there's 2 of everything, be really careful when you pull up that screen. When you pull up your 2 sample z-test, it's going to prompt you for a lot of different things. You are going to see sigma 1, sigma 2, x bar 1, n1, x bar 2, n2, and then you're going to see not equals, less than, greater than. Okay, so the order is a little weird, but just kind of pay attention and make sure you're inputting the correct values. Sigma 1, this is your standard deviation from that first sample. Sigma 2 is the standard deviation from the second sample or second group. Then it goes x bar 1, that is your mean from group 1, and is the sample size from group 1. Okay, so they kind of go 1, 1 there together. And then they go back to group 2. You need the mean from group 2. And 2 is the sample size from group 2. And then when it comes to the symbols, remember you decide that based off of whatever was in your alternative. You're going to hit enter. And just like before, the z is your test statistic. P-value is also located in there if you want to go that route. Okay. Very, very familiar steps. Okay, so what? Everything's doubled. The only thing that's still different is that calculator button. Everything else is still going to be the same. So when it comes to doing some examples up here, if I can get my screen up here. There we go, that's where I want it. Okay, so let's run through a couple of these. An advertising executive claims that there is a difference in the mean household income for credit card holders of Visa and of MasterCard. The results of a random survey of 100 customers from each group are shown below. That's in the box they're giving you down here. The 2 samples are independent, so they're kind of taking care of our criteria. Do the results support the executive's claim? They want us to use a significance level of 0.05. Now, if we're going to go through our steps, the first thing we always do is we start with our null and our alternative. Well, I'm going to use mu1 and mu2. I'm using that first format. And let's see, we are claiming that there is a difference. We don't know if it's bigger, smaller, anything like that, but maybe just that there is a difference not equal to. That's going to make our alternative the claim, and the opposite equals into our null. All right, next thing is we like to state our level of significance. They gave us it as 0.05. That is helpful for the next step, our critical value, because this is a 2-tailed test. We need to take half of our alpha. And what that's going to do, if I use my inverse norm in my calculator, half of 0.05 is 0.025. The calculator is going to give me 1.96. And since it is 2-tailed, you should add the plus or minus. From that, you can start your sketch. I'm going to work over here on the left below the box. It is 2-tailed, so I need 2 shaded sections. And we've got our critical value as a negative 1.96 and a positive 1.96. Again, those are the vertical lines separating the shaded part from the white part in the middle. After the critical value, we're pretty much into calculator territory. Okay, we're going to aim for our z-test statistic and our p-value. Both are going to come out of the calculator. This is where you need that 2-sample z-test. It will walk you through the prompts. Now, up here at the top, they're giving you S's. That is still your standard deviation. The calculator will use the mu symbol. Don't get mixed up by that. But you insert all of that information. It's already organized in that box. You just got to put it in the right order in the calculator. And then when you hit enter, you should get a z-test stat of negative 1.77 and a p-value of 0.08. Now, for the sake of following the directions on the front of your notes, we're going to do the graphing. If I plot negative 1.77, it's to the left of my picture, but not quite into our shaded part. So if I'm in that white area, we are going to accept the null. And when you check out your hypotheses, our claim is in the alternative, so we're going to do the opposite and reject our claim. Again, I cannot stress enough how much this is similar to the last chapter. The only thing that's different is the button on the calculator. Okay, everything else, same process. Okay, to reiterate, let's try one more. Okay, second example, AAA claims that the average daily meal and lodging costs for vacation in Florida are greater than the same cost for vacationing in Delaware. I don't know why they chose those two states. Okay, the table below shows the results of a random survey of vacationers in each state. Again, you've got your box right below with all your info. The two samples are independent, so we've got our criteria. Met at a significance level of 0.05. Do we have enough evidence for our claim? Well, we are claiming this time that the cost for Florida, okay, this is going to be group 1, are greater than the average in Delaware, that's group 2. Notice group 1, group 2 given in the box. So when I go to set up my null and my alternative, when I compare mu1 and mu2, greater than, well, that's a greater than symbol, which is putting my claim in the alternative. We've got less than or equal to happening for our null. When it comes to our significance level, they gave us 0.05 again. Now, that's going to go and be handy for our critical value. This one is a right-tailed test. So you need to do 1 minus alpha. And what that means, if I do my inverse norm again, 1 minus 0.05 is 0.95. And then the calculator will give me a positive 1.645. If you are right-tailed, you should be getting a positive critical value. When I start my sketch then, right-tailed, shading to the right with a positive 1.645. Then I can go to my calculator to find my test stat and my p-value. Again, both of these are coming out of the calculator by running, hold on a second. Aha, there we go. I can outsmart my computer. Okay, we're running that 2-sample Z test. Okay, again, they are going to walk you through all the information. Just take it out of your box, put it into the calculator. I got a Z test stat of 4.54. Careful when you pull the p-value out of the calculator. You do see a 2.78. Doesn't really make sense because your probability should never be over 1. So how do you get 2.78? Well, if you look at the end, you see an E with a negative number. I didn't write it down, I'm terrible. But essentially, if you have that scientific notation, you've got 0. This is a very, very, very small p-value. Even when you graph it, 4 is so big compared to everything else when you plot it on your picture, we're definitely rejecting this null. So we are going to reject the null and do the opposite for our claim. We are accepting the claim. Very similar steps. That 2-sample Z-test is the new option in the calculator. And then you do have a couple practice problems for homework. This video will also be on my website. I know I went a little fast, so if you need to catch up, watch it again, slow it down at home, you are more than welcome to do so, and I will be back tomorrow.